Alright, hello everyone. Gonna do a little quick video on constitutional isomers, and we'll do some practice on finding all the constitutional isomers. So, what is a constitutional isomer? Basically, a constitutional isomer has the same molecular formula, but different arrangement of atoms. Different atom arrangement, we'll go with that. Just something to kind of know that we'll get into later is a stereoisomer, which is same formula, same arrangement of atoms, but different spatial arrangement. Another way you could say it is the molecular bonds are in the same order. So for this video, we're going to work with saturated hydrocarbons. So it's only single bonds. Saturated hydrocarbons have the formula Cn H2n plus 2. Basically, for every carbon, each carbon in the middle of the chain has 2 hydrogen on it, and then the end carbons will have 3. That's kind of what that formula says for if it's just a long single chain. So we'll just jump right into an example, kind of get you started. And we're going to do the naming. At this point, we didn't go over how to name using the IUPAC system, but this will kind of start getting you there in the next video. We'll go over all those rules. So let's name all the bond line structures. Let's draw all the bond line structures for the constitutional isomers with the formula C6H14. So we see that's saturated because if N is 6, so there's 6 carbon, N is 6, then the amount of hydrogen for it to be saturated would be 6 times 2 is 12 plus 2 is 14. So if we had one chain, that would be 6 carbons. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That's hexane. Hex for 6, and ANE is an alkane. So then let's kind of shorten that chain. We'll go 1, 2, 3, 4, 5. And have it like this, or 1, 2, 3, 4, 5. So just numbering this chain, just we might not know, is 1, 2, 3, 4, 5. 1, oh. And the other side you go where you get that branch. 1, 2, 3, 4, 5. You want the branch to be at the shortest possible or the lowest possible number. In both cases, it's both 2. So our parent chain is 5. Our branch is at 2. So that name would be 2. We know it's a methyl group. 2-methyl, and we have a 5 as a parent chain. That's 2-methyl pentane. Alright, let's keep going with that. So instead of just having it at the 2, we can have it right at the 3. 1, 2, 3, 4, 5. Right at the 3, that would be 3 methyl pentane. We could have it both on the 2 carbon. 1, 2, 3, 4, 5. Oh, sorry. 1, 2, 3, 4. We'll both have it on the 2. Or we can have it 1, 2, 3, 4. Both on the 2. Just to name it again. Come on. So this would be 2, 2. We have 2 of them, so it's 2 methyl groups, so it's dimethyl butane now, as our parent chain is only 4. And then the last way we can do this There's only one way, so that's good. It would be 2, 3. Either way that you number this one, 1, 2, 3, 4, would be the same thing. So this is 2, 3, 2 methyl groups, so dimethyl butane. So let's go over one more example where there's 1, 2, 3, 4, 5, 6, 7, 8, 9 for the formula C7H16. So if you guys wanted to practice, you can stop now and I'll kind of run through them, going from the longest possible chain, heptane, down to butane. So we said 1, 2, 3, 4, 5, 6, 7, 8, 9 possible. So I'm just going to jump right in it. This would be a time to pause. So we just do a chain, long parent chain, 1, 2, 3, 4, 5, 6, 7, be heptane. Kind of shorten it by 1 now. Now we have 6 in the parent chain, 1, 2, 3, 4, 5, 6. Let's draw 2 of them, 1, 2, 3, 4, 5, 6. Depending on how you number it or where you want to have your methyl group. This would be at the 2 methyl hexane now that we have a 6 parent chain. And the way that we kind of go about this and how we're writing it, if you have a test question like this, it's good to start with the long chain and shorten it up. So now at the 2, I can move it to the 3. To the 3 carbon. There's 2 possibles, 1, 2, 3, 4, 5, 6. 1, 2, 3, or 1, 2, 3, 4, 5, 6. 1, 2, 3. It's just 3 methyl butane. 3 methyl hexane. Oop. Now we can have it at the same carbon. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Both will be on the 2 carbon. So now that we have 2 on there, you write 2, 2. So there's 2 of them on there. 2 methyls, 2, 2 dimethyl pentane now that we have a 5 parent chain. 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7. That would be 2, 3 dimethyl pentane. Or we can go like this, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. 2, there's only 1 for that. 2, 4 dimethyl pentane. We got 2 more for the pentane. They can all be, 2 of them can be on the 3 carbon. 1, 2, 3, 4, 5, 6, 7. 3, 3 dimethylpentane. 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 3 ethylpentane. And so we've been working with a methyl group so far. Now we can have a ethyl substituent there. And now we're going to shorten the chain again. 1, 2, 3, 4, or 1, 2, 3, 4. I have 2 on number 2. 1 here. This should be 2, 2, 3. Let's number it. 1, 2, 3, 4. You don't want the lowest number to have the most possible substituents, which would be 2 for the lowest. 2, 2, 3. We know there's 3 methyl groups, so 2, 2, 3 would correspond to the 3 methyls, trimethyl butane. And just to kind of show you, we'll zoom out a little bit. So this was all constitutional isomer practice. We know they all have the same formula, but different atom arrangement. We know stereoisomers have the same formula. It'd be the same bonds of atoms, but in different spatial arrangement. We'll go over that in a later video. This was working with saturated hydrocarbons, where there's only single bonds. In alkanes, or saturated hydrocarbons, each carbon in the middle would have 2 hydrogen, while the ends would have 3. We started with C6H14 hexane. The parent chain went down to pentane, and eventually butane. And same thing here, we went to heptane for C7H16. We worked down to hexane. Parent chain dropped down to 5-pentane, and eventually back down to butane. Thank you. Next video we will go over the IUPAC naming system. This is what this was in the next video. Thank you. See you soon.